tissues are divided into three types based on the regenerative capacity: the labile, the stable, and permanent. The labile tissues possess stem cells that continuously cycle to regenerate the tissue. For example, labile tissues can involve small and large bowel because they have stem cells in the mucosal crypts, as shown over here in figure 2.5. These are the intestinal crypts with stem cells. The labile tissues also include the skin, and they include, or it's because they have stem cells in the basal layer, as shown in figure 2.6. Right over here, stem cells in the basal layer. And then labile tissues are also found in the bone marrow, as they have hematopoietic stem cells. So small and large bowels, tissues, the skin, and the bone marrow with the hematopoietic stem cells are examples of the labile tissues. On the other hand, the stable tissues are comprised of cells that are quiescent in the G0 phase of the cell cycle, but they can re-enter the cell cycle to regenerate the tissue whenever necessary. So the classic example is the regeneration of the liver by compensatory hyperplasia after partial resection. Each hepatocyte will produce additional cells and then re-enter quiescence. So that is one classic example of a stable tissue that enters the quiescent G0 phase of the cell cycle. Okay. And then lastly, permanent tissues lack significant regenerative potential. So the classic examples include the myocardium, or the heart muscle tissues, the skeletal muscle, and the neurons. And that is why you have to protect your neurons and your heart muscles as carefully as possible. And then now let's talk about repair. So repair involves the replacement of the damaged tissue with the fibrous scar rather than native tissue, because replacement of damaged tissue with native tissue would be classified as regeneration. So with repair, the key difference is that there's a replacement of damaged tissue with the fibrous scar, and this is going to occur when regenerative stem cells are lost, such as a deep skin cut, or when a tissue lacks the regenerative capacity. So, when the stem cells are lost, one classic example of that is a deep skin cut, because at that point, even the basal layer of the skin has been cut off. And remember that we talked about that the basal layer of the skin contains the stem cells for skin regeneration. So that makes sense why deep skin cut can destroy regenerative stem cell potential in the skin. We also talked about how the myocardium is a permanent tissue and thus lacks significant regenerative potential, which is why a healing after a myocardial infarction will only lead to fibrous scarring. And here's a figure that shows an example of a myocardial scarring. So, and then we have granulation tissue formation that is part of the initial phase of repair. And here is an example of granulation tissue formation. That is the first initial phase of the repair process. And the granulation tissue will consist of fibroblasts, capillaries, and myofibroblasts. Fibroblasts contain or deposit type 3 collagen. Capillaries responsible for depositing type 3 collagen. The capillaries will be responsible for providing nutrients. And then eventually, after all these processes occur, there's going to be a scar formation in which the type 3 collagen becomes replaced with the type 1 collagen. So, the type 3 collagen is pliable and it can present in granulation tissue, also the embryonic tissue, the uterus, and the keloids. The type 1 collagen has high tensile strength, and so it will be present in the skin, the bone, the tendons, and most organs. And then the enzyme called collagenase will remove the type 3 collagen, and this enzyme, the collagenase, will require zinc as a cofactor in order to be activated, or in order to carry out its function. So remember, type 3 collagen is pliable, while type 1 collagen has high tensile strength. So, let's talk about the mechanisms of tissue regeneration and repair. So, tissue regeneration and repair, it is going to be mediated by paracrine signaling through growth factors. Specifically, macrophages will secrete growth factors that will then target the fibroblast. Then there's going to be the interaction of the growth factors with the receptors. So, for example, there's going to be an interaction between the epidermal growth factor with the growth factor receptor. And once there's this interaction, there's going to be gene expression and cellular growth. So, in other words, the interaction of the growth factors with the receptors will result in gene expression and cellular growth. And remember that a paracrine signaling is involved with the growth factor secretion, and that the macrophages will typically secrete the growth factors that will then target the fibroblast. So, examples of mediators for tissue regeneration and repair include the transforming growth factor alpha, or TGF-alpha, and this is responsible for serving as epithelial and fibroblast growth factor. The TGF-beta, which is an important fibroblast growth factor. This is also going to inhibit inflammation. And then the platelet-derived growth factor, which is a growth factor for the endothelium, the smooth muscle, and the fibroblast. And then the fibroblast growth factor, which is important for angiogenesis, and also mediates the skeletal development. And then lastly, the vascular endothelial growth factor, or VEGF, or VEGF. This is critically important for angiogenesis. So remember that TGF-alpha, responsible for serving as epithelial and fibroblast growth factor. TGF-beta, also an important fibroblast growth factor, while inhibiting inflammation. Platelet-derived growth factor is growth factor for endothelium, smooth muscle, and fibroblast. And fibroblast growth factor, which is important for angiogenesis, while mediating skeletal development. And then vascular endothelial growth factor, which is also important for angiogenesis. Now let's talk about normal and aberrant wound healing. So, generally, cutaneous healing will occur through primary or secondary intention. Primary intention is where wound edges, or the wound edges, are brought together. And this leads to minimal scar formation. One example of wound edges being brought together include suturing of a surgical incision, afterwards, myofibroblast, then contract the wound, and then this leads to scar formation. So once again, secondary intention is where edges are not approximated, and then the granulation tissue fills the defect. Myofibroblast then contract the wound, thus forming a scar. And then we have delayed wound healing. This typically occurs in the infection, which happens to be the most common cause of delayed wound healing. And Staphylococcus aureus is the most common offender of this delayed wound healing. And then delayed wound healing, it can also occur in vitamin C, copper, or zinc deficiency. So, in vitamin C, it is an important cofactor in the hydroxylation of proline and lysine procollagen residues. And it's because hydroxylation is necessary for eventual collagen cross-linking. So always think about vitamin C when thinking about a very critical cofactor in the hydroxylation of proline and lysine procollagen residues. Because hydroxylation is necessary for eventual collagen cross-linking. And then copper is a cofactor for the lysyl oxidase, which then cross-links the lysine and hydroxylysine to form a stable collagen. And then the zinc is a cofactor for the enzyme collagenase, which replaces the type 3 collagen of the granulation tissue with the stronger type 1 collagen. And then other causes of delayed wound healing include foreign body, ischemia, diabetes, and malnutrition, so keep those in mind. Now, the ascens is the rupture of a wound, and it is most commonly seen after abdominal surgery. Hypertrophic scar is an excess production of scar tissue that is localized to the wound, as shown here in figure 2.9. So here's a hypertrophic scar. Once again, that's excess production of scar tissue that is localized to the wound. And then keloid is the excess production of scar tissue that is out of proportion to the wound, as shown in figure 2.10. So here's an example of a keloid with that excess scar tissue production that extends beyond the wound location. So this is characterized by the excess formation of type 3 collagen. There is genetic